a new chapter actually. So chapter 18, which we started, we will postpone it for after we finish this chapter. Then we will simply continue the chapter of the Alkene. So today we'll start chapter 5 according to the outline, and the new outline, which is based now on edition 9. Chapter 9 is about something called stereochemistry at tetrahedral centers. What's the stereochemistry? Stereochemistry, it's the chemistry which deals with the three-dimensional view of a molecule. So it is the science which deals with spatial, let's say, arrangement in space, or it's simply the sense which deals with arrangement in three-dimensional structures. So this is simply the meaning of stereochemistry. First of all, let us also define the three-dimensional structure at a tetrahedral. Generally speaking, we view a tetrahedral by this way. We always view a tetrahedral by two lines in the same plane, and one line above the plane and one line below the plane. Again here, this is the tetrahedral structure as we said before. And the meaning of each line in the three dimension, that this line here, the normal line, we should imagine that this is on same plane. And any bond with this shape means this is above the plane, and this is here, as we said before, it means below the plane. From now on, you should all try to imagine, because without imagination, we cannot actually deal with this very important aspect of chemistry, which is the stereochemistry. Stereochemistry is about imagination. Let me show you again. This is the tetrahedral tetrahedral compound, or tetrahedral molecule. As you can see here, when I want to view it in my brain, or when we want to view it in two-dimensional, simply we imagine that there are two atoms which are, you can see them here, like the black ones here. The two atoms in the same plane, as you can see it. Do you follow me? So they are in the same plane of my hand. One atom is above the plane, which is, in this case, the red atom, and one atom is below the plane, which is the yellow atom. Do you follow me? Got it? So this is always how we view a tetrahedral structure in the three-dimensional, or simply transferring the view from two-dimensional to three-dimensional and vice versa. Do you follow me? So this is always the case here for the tetrahedral and the arrangement of atoms in space. Now, in principle, in life, we have some objects, they have a property of chirality. Let me just explain the meaning now. I just want to make this example, and then we go back to our board. Now, in reality, in life, for example, there are objects which has this property. You can imagine my right hand. If you simply view your right hand, if you put it in front of a mirror, what you will see your left hand. Is that true? Right? Now, when you try to superimpose these two objects over each other, you will see that they will not superimpose into each other perfectly. Do you follow me? So the thumb will be away from the thumb, and so on and so forth. So they will not superimpose into each other. So this is what we have. Some object have this property. This property, this is what we call it chirality. When this is all about this chapter, the whole chapter is about this property. Do you follow me? So in life, some objects or molecules have what we call it chirality property. And what we mean by chirality property, chiral means object and its mirror image are not superimposable into each other. Are not superimposable on each other. Is that clear what I mean by chirality? So you must imagine that this property is not a property of any object. It's only for few objects in life. For example, yes, everything. Now, all right, for example, these two objects. If you place this object in front of a mirror, you will see its mirror image, isn't it? Because that's actually normal. If you place anything in life in front of a mirror, what you will see its mirror image. But if you try to superimpose these, you will find they are superimposed perfectly to each other. Do you follow me? So this type of objects or molecules does not show what we call it chiral property. Chiral property is only for objects in which the object and its mirror image are not superimposable, like the right hand, the left hand. Like the gloves, for example. If you try to view a glove in a mirror, in front of a mirror, what you will see its left hand. If you try to superimpose, they are not superimposable into each other. Is that clear? Is there any question about the chirality property as a property of some objects or molecules in life? Is there any question about it, about chirality property so far? Is there any question? Someone respond, please. All right, thank you. Okay, now let's just imagine or just check this here with molecules here. What will be the case with molecules? Let's just simply imagine a molecule with tetrahedral like this. Now here you can see this molecule here, for example, this is a tetrahedral atom bonded to how many different atoms or groups here? How many different atoms or groups is bonded to the tetrahedral here? Imagine, of course, each color is an atom or group. How many different atoms or groups here? You're right, but different, I mean different. How many types? How many types? 3, because black like black here. Do you follow me? Now, in this case, let's see if a molecule like this, does it contain a chirality property or not? Do you follow me? Now, if you view a molecule, if you place this molecule in a front of a mirror, what you will see this, its mirror image, isn't it? Do you follow me? Right? Now, let's try to superimpose these two objects into each other. See? If you try to superimpose, you will see you can superimpose every atom on its type. So the black goes on the black, black on black, yellow on yellow, red on yellow and red. Do you follow me? So These two objects are what? Are they superimposable now, impossible, or super non-impossible? What they are? These two objects, they are what? Superimposable into each other. So in this case, for example, like if we have a tetrahedral connected to, let's say, for example, A, B, C, and C. In this case, this object and its mirror image. So the mirror image here will be like this. A, B, I'll just view it a little bit further. A, B, and then C, C. You can see these two, they are mirror images, but they are what? Superimposable into each other. Do you follow me? So when we will see the chirality property then, or in which molecule can have the chirality property? Actually, just to make it short and to make it simple, the molecule actually in chemistry, in organic chemistry, which shows the chirality property, it's a carbon, and a molecule contains a carbon connected or bonded to 4 different atoms or groups. For example, this one, can you see it? It's connected to 4 different carbons, atoms or groups. Imagine, of course, that each color is a different atom or group. Do you follow me? Now, if we place this molecule here in the front of a mirror, we will see its mirror image. Do you follow me? Now, if you try to superimpose these into each other, you will not be able to do so. These two molecules are not superimposable into each other, exactly like my right hand and my left hand. Again here, my right hand and left hand, they are just mirror images to each other, right? But they are not superimposable into each other. They cannot superimpose into each other. Similarly, in organic chemistry, any compound, any organic molecule contains a tetrahedral atom connected to 4 different atoms. This molecule will contain chirality, or will have chiral property. So in such a case, this molecule and its mirror image, they are not superimposable into each other, as you can see. For example, the black can superimpose into the black. The blue here can superimpose into the blue, but the yellow and the red will never superimpose into each other. Is that clear? Is this clear, guys? All right, so which molecules then show chirality in organic chemistry? Let's see here. Or when the molecule can show chirality, let's say when molecule can show chirality. If it has a carbon or tetrahedral carbon, like in one condition, connected to four different atoms or groups. Do you follow me? So this is the condition actually in such a condition, this is the condition in order for a molecule to possess or to have the chirality property. It must be having what we call it the tetrahedral carbon, and this tetrahedral carbon must be connected to 4 different carbon atoms, to 4 different atoms or groups. This tetrahedral atom, which is connected to 4 different atoms or groups, this is what we call it chiral center, or in some textbooks we call it Stereocenter. So what's the chiral center in this case, or a stereocenter? The chiral center, it's a carbon atom, it's a tetrahedral carbon connected to 4 different atoms or groups. Do you follow me? So chiral center or stereocenter, it's a tetrahedral atom connected to 4 different atoms or groups. Do you follow me? So this is one way to guess if a compound contains the chirality property or not. The other way, or the other method, if the compound contains no plane of symmetry, no plane of symmetry. Do you follow me? So this compound here, for example, we said this is chiral because it has a stereocenter. This stereocenter, this is a tetrahedral atom connected to 4 atoms or groups. At the same time, this here, it is chiral because simply there is no plane of symmetry. And the plane of symmetry, a plane of symmetry, it's like imaginary plane. For example, if you imagine this is a plane of symmetry. It is an imaginary plane can pass through any molecule, and which in such a case it will divide it into 2 halves. Here you can see there is no way to, for example, to allow this to pass through the red and the blue. It will make it 2 halves, lakin the yellow here will be different than the black. This applies to anything else. Do you follow me? But if you imagine, if you think here the previous example, does this compound contain a plane of symmetry, a stereocenter or not? Does this compound here, as you see it, does it contain a chiral center or a stereocenter? No, does not. Why? Why it does not, Maria? Why it does not show or does not contain a stereocenter? Maria or Amani, why this compound or this molecule does not have a stereocenter or chiral center? Because it's connected to 3 different atoms, but not 4. Because not all groups are different. Do you follow me? Now, the question is, any compound like this is here, we call it, if the compound contains, let me just write it, first of all, write it and then come back to this. If the compound contains a stereocenter, then we call it chiral, and which means the object and mirror image are not superimposable into each other, and thus we call them the object and mirror image are different compound, and we call them enantiomers. Do you follow me? So this is first case. The second case, if the compound contains no stereocenter, then we call this achiral. And the meaning of achiral, it means the opposite of chiral. So it is achiral, which means in this case the object and its mirror image are the same. Again, I will just use the models for the time being, and then I'll start after that, just make the drawings on the board. You follow me? Now let us see. Now this object, again, does this object contain a stereocenter? Very quickly, please. Does this object contain the no stereocenter in this object? Therefore, now if you place this object in front of a mirror, you will see its mirror image, right? If you try to superimpose, since this object does not contain a stereocenter, we call this achiral. We call it achiral. Does not have what we call it the chirality property. What does that mean? It means this object and its mirror image, they are superimposable into each other. They can superimpose into each other, which means they are identical. They are the same object. Do you follow me? Is that clear? This is the meaning of the achiral molecule. While for the chiral molecule, let's see, does this object contain stereocenter or not? It does contain a stereocenter. Do you follow me? Now, if we place this object in front of a mirror, we will see this is its mirror image. My left hand is its mirror image of my right hand, isn't it? If you try now to superimpose these two molecules, they will never ever superimpose. Therefore, this object and its mirror image, we call them enantiomers. They are different compounds. They have different physical and physical properties. Do you follow me? So they are totally different compounds, and these are actually two stereoisomers in this case. And this compound, we call it chiral compound in this case. So any compound contains a stereocenter, we call it chiral. And the meaning of that the object and its mirror image, they are not superimposable into each other. And therefore, these two objects, we call them enantiomers. Do you follow me? So, what's the meaning of enantiomers again? Enantiomers, they are a molecule and its mirror image. Molecule and its mirror image, and which are simply non-superimposable into each other. Is that clear so far? Is there any question about what we said so far? Is there any question? Wonderful. Now, so again here, in order to understand the chirality and the chirality property, as you can see, this object, does it contain a plane of symmetry? Again, the plane of symmetry is imaginary plane, passes through a molecule and divided it into two equal halves. Now here, because this compound, it is chiral, it will never possess a plane of symmetry, because wherever you try to pass this plane of symmetry through, will never divide this molecule into two halves. So always there is a connection between chirality and plane of symmetry. So chirality, it's just, I'm just going to write it here. So for a compound, any object to be chiral, it must contain or possess a stereocenter, or it must possess no plane of symmetry. Do you follow me? يعني in other words, for example, يعني just for your imagination, we know that my right hand is different than my left hand. In other words, we know that my right hand is different than its mirror image, which is my left hand. But how can I know, how can I guess like the hand as an object, if it possesses chirality or not? It's the presence or absence of a plane of symmetry. So here, this object has no plane of symmetry. If you try to divide your hand by any means, you will never do so, because if you imagine that the plane of symmetry can pass through all of this plane, the upper hand is different than the inner part. Do you follow me? And therefore they are not mirror images. Therefore there is no plane of symmetry actually in the right hand and the left hand. Therefore it's chirality. In other words, chirality, it's always connected to the presence of, let me just rewrite it this way, the presence of a stereocenter and the absence of the plane of symmetry. You write it this way. Any object to be chiral, there should be presence of a stereocenter or absence of a plane of symmetry. Do you follow me? And either which, this means that definitely if a compound has no plane of symmetry, that means definitely it must be containing a stereocenter. If a compound contains a stereocenter, then definitely it must be having no plane of symmetry. Is that clear so far for the models and so on, and for the meaning of chiral object and the meaning of enantiomers, the meaning of the plane of symmetry? Is that clear so far, guys? Is there any question about this aspect? Because it's extremely important to understand this aspect, because otherwise now we will just continue to look for examples and look for more and more examples. Is there any question so far? All right, let us see. Let's just take some examples and see if you get the idea or not. Which of the compounds, or which of the following compound is chiral, or which of the following compound is achiral? Let me just take the same examples, but you have it in the slides, for example. Is this compound chiral or achiral? Is this compound chiral or achiral? Just some answers, please. Is it clear now? Is it clear now? Aisha, is it clear, the board? Okay, so is this compound chiral or achiral? Actually, this compound is chiral. Why? Because it contains a planar symmetry. Let's simply, it contains a stereocenter, sorry. Let's simply determine or assign the stereocenter by a star like this here. Do you follow me? Now, this carbon here is a stereocenter because it contains, this carbon is connected to 4 different groups or atoms. You can see here, this connection is proper, right? And there is another atom here which is not appearing, is the hydrogen. Do you follow me? So 1 group, 2 group, and this here connected to CH2, but this arm is different than this arm, and therefore this here is different than here, and therefore we have 1, 2, 3, 4. So the 4 are different, therefore this carbon, which is characterized by the star, this is what we call it a stereocenter. Is that clear? Is this clear, guys?
Doctor?
Yes, please.
What is the difference between 3 and 4?
Good question. The difference, as you can see here, this is CH2, right? Right? And this is CH2, according to the bonding. But this CH2 is connected to nitrogen. This CH2 is connected to CH2. So any slight difference is different. Khalas. So these 2 groups are different. Therefore, we consider this carbon here to be a stereocenter. Is that clear?
Yes.
Sure. Any other question? Maria, is that clear? Wonderful. So let's take another example here. For example, CH3, CH, Br, CH3. Is this molecule chiral or achiral? اللي هو 2-bromopropane. Is this molecule chiral or achiral? It is achiral. Why, Maria, it's achiral? Why it's achiral? In other words, it contains no stereocenter. There is no stereocenter. That's actually the case. So this is achiral. طيب, do you understand the meaning of achiral? What does that mean, achiral? Yani, here you said, guys, or we said, this is chiral. And here we said this is achiral. What does that mean? We are not just dealing with words, we just deal with understanding. What's the meaning of achiral? What's the implications of a presence of a stereocenter in this compound? What does that mean? Any answer? What's the meaning of chiral here?
The compound connected to different groups.
Right, but what's the implication? What we conclude? So if a compound is chiral, so what? What does that mean? What's so important about it? What's so special about it?
As an image mirror, it's not superimposable.
Non-superimposable. In other words, it's like it has the handedness property. Do you see my hands, guys? You see my hand? I have my right hand and I have my left hand. My right hand will never be my left hand and vice versa. Do you see? Right? This property, which is the chirality, or sometimes we call it handedness property. If you have a compound which is chiral, it means you have 2 forms of it. you have the object and the mirror image. And the relationship between them, they are enantiomers. They are not the same. They are like two different compounds. Do you follow me? So we have like, in this compound, since it is chiral, because or due to the presence of a stereocenter in it, it means the object and its mirror image are non-superimposable into each other, and therefore we should conclude that they are enantiomers, which means it's like we have two types of this compound. We can have this compound and its mirror image. Here we have this compound is achiral, which means the object and the mirror image are the same. Yani we don't have like handedness property. We don't have the right hand side molecule and the left hand side molecule. We just have the same molecule all the time there because it is achiral. But since this compound is chiral, then we must conclude that this compound show or possess what we call it the handedness property, which means as if here we have two molecules, one like my right hand, one like my left hand. And these two molecules are totally different. These molecules are stereoisomers. These two molecules are non-superimposable. The relationship between these two molecules are the molecule and its mirror image. That's actually the consequences for classification of any compound as chiral or achiral. I hope that's very obvious and very clear for all of you, because that's actually the heart of the whole topic, the heart of the whole chapter, the center of everything. You follow me? Is this understanding, the chirality, chiral property, the meaning of it, when we should expect it, and what's the consequences of the presence of chirality property or not. Is that clear, guys? Is there any question about the chirality, the chiral and achiral object, and the implications of that? Perfect. Okay. Now, but the question is, in reality, in life, my right hand and my left hand, I categorize them or I classify them by saying my right hand, my left hand, black hand. In organic chemistry, we classify the name of every compound by IUPAC nomenclature. Do you follow me? So we give IUPAC name here, IUPAC name there. So what's the difference in the naming of the two enantiomers, or how to differentiate two compounds actually in organic chemistry? That's actually what will lead me to directly going to the nomenclature or R and S absolute configuration of the two compounds. Let me just go to this here. Now, just how to differentiate, let's say, or naming of the two enantiomers, let's say. There are different topic titles of this section. We may call it Kahn-Ingold pre-log rules. Or we can say it absolute configuration R and S. So in the enantiomers are classified, enantiomers are given are given same IUPAC names with only difference one is given the R and the other is S. So that's actually the only difference in the IUPAC nomenclature of the two enantiomers. One will be R, one will be S. Now, we are going now to discuss the rules which leads to this knowledge. When I say this R and when I say this S. So, determining the absolute configuration, this is what we call it can-ignore preload rules. Now, the first rule in this assignment, first we must prioritize if all atoms connected to the Stereocenter. So we must assign priority for the 4 atoms, for the 4 atoms directly attached to the Stereocenter. So this is extremely important rule here. The first rule, we must assign priority. And the priority simply here, we must give it the name, the priority by giving either 1 or 2, 3, 4, or A, B, C. Let's say give it 1, 2, 3. I just want to make it the same as in that book. Anyway, now the priority here, according to, let's say, according to the atomic number. Do you follow me? So, for example, here, let me just give you some examples for the first rule. This carbon attached to BrCH3 hydrogen. Suppose, just imagine this. So this carbon here contains, or this carbon is a Stereocenter because it is attached to 4 different atoms or groups, right? So, but what are the atoms directly attached to the Stereocenter? We have the bromine, we have the chlorine, we have the hydrogen, and we have the carbon in here. Do you follow me? According to the atomic number in the periodic table, the atomic number of the bromine, let's say it's here. The bromine has 35 atomic number, chlorine is 17, hydrogen is 1, and carbon is 6. So in this case, our classification must be the higher priority will be the higher atomic number. So this is number 1, or ranking number 1. This must be number 2, and this must be number 3, and this must be number 4. Do you follow me? This is how we assign priority of all atoms attached to a Stereocenter. Right?
How it is CH3, 6?
We are talking about the atomic number. This is from periodic table. Do you follow me? Because it's carbon. We are talking about the atom directly attached to the Stereocenter. Is that clear?
Yes.
So the atom directly attached to the Stereocenter, regardless of CH3 of anything else here. Now here, the directly attached to the Stereocenter is carbon. The atomic number of the carbon is 6. Therefore, when you compare atomic number of 35, 17, 6, and 1, then this must be the highest priority. This is the second, this is the third, this is the fourth. Is that clear, guys? Is that clear? Any question about it? All right. Okay. Now, so this is the first rule. So the first rule is assigning priority based on the directly attached atom. If for any reason the directly attached atom cannot be determined, then we look forward for the next atom. So here, if a decision cannot be reached by ranking the first atom in the substituent, look at the second or third or fourth or whatever until you found the decision. Do you follow me? So if decision cannot be made from the directly attached atom, let's say second rule, if decision cannot be made from comparing directly attached atoms, compare the second or third or fourth etc. until a decision can be made. So this is the second rule. Yani, if we cannot directly compare, if we cannot compare the directly attached atom, then we must compare further until we find a decision. Let's take an example. For example here, CH3 CH2 CH2 CH3 CH2 CH3 CH3 and then CH3. Right? Now again we are dealing with a stereocenter. Yani there must be a stereocenter in order to have for all what we say any meaning. Do you follow me? Now, as you can see, the directly attached atoms to this stereocenter. What are the four directly attached atoms to this stereocenter? What are they? Are they different or they are the same? This is the question. Are the directly attached four atoms to the stereocenter, are they different or the same? They are the same, Jihad. Right? So they are the same because all are carbons. Here carbon, 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 carbon. So in this case, the first rule cannot be applied. Do you follow me? Yani we cannot have a decision by directly comparing the directly attached atom to the stereocenter. So what should we do? In this case, based on the second rule, we must compare further. In other words, we must compare the atoms attached to these atoms and then compare further until we find the decision. What does that mean? Here, we focus our attention to this carbon, to this atom. When we compare these directly attached atoms, we said we cannot make a decision. So what should we do? We now compare the atoms attached to these. What are the atoms attached to these? What are the atoms attached to this carbon, guys? Here, maybe saying by butter here would be. What are the atoms attached to this carbon? Just tell me, what are the atoms attached to the specified carbon in here? Taif and Maria, just be more specific. What exactly have? We have two hydrogens, hydrogen and hydrogen. Isn't that true? And then we have a carbon. And هذا الكربون, this carbon, and these 2 hydrogens. Is that clear? Right? So we have carbon and 2 hydrogens. Perfect, Amani. That's absolutely true. So the atoms attached to this carbon are carbon and 2 hydrogens. What are the directly attached atoms to this carbon here? To the second carbon? What do we have here? Yeah, just write it as I do. Write it as I make here. Like write it hydrogen, hydrogen, hydrogen. Sorry. So what are the directly attached atoms to this carbon? What do we have? Very quickly, please. Maria, if there must be 3, there must be 3 atoms. Then one will be attached to the stereocenter. The other 3 now we are comparing them. So here to this carbon we have carbon, carbon, and hydrogen. Is that true, Maria? Oh, yes, perfect. Jahad, that's true. Carbon, carbon, hydrogen. So, what are the atoms attached to this carbon here? The atoms attached to the last carbon are what? Hydrogen, hydrogen, and carbon. Exactly. Hydrogen, hydrogen, and carbon. It's very obvious now. We can conclude something from this comparison. Which is number 1? Which is the highest priority atom must be? طبعا the highest, يعني the groups what we have the isopropyl, the methyl, the propyl, and the ethyl. Which one must be, according to this classification, the highest priority atom, group? What's the name of this group, Mayasa? Exactly, isopropyl. So this we can conclude that very obvious that this here is the highest priority atom. Carbon, carbon, hydrogen is the highest. What should be the least priority atom or group in this case? What is the least, now in number 4, what is the least priority atom or group? It's exactly the methyl. So this is number 4. So from this comparison, we could know now, we could compare number 1 from the 4. But now when we compare this with that, we will see that this here is the same like this. In other words, the next directly attached atom are the same in these 2 groups. Therefore, we cannot now decide. We must continue the comparison further until we find a decision. Do you follow me? Now, how we do so? Now, we continue further. Now, you can see, now this here, we cannot make a decision so far, but what we can do, we can continue comparing further until a decision can be made. In this case here, when we compare further, you will see, let's compare this carbon. What are the atoms attached to this carbon, guys? Very quickly, please. What are the atoms attached to this carbon? What are hydrogen, hydrogen, carbon? Perfect. Hydrogen, hydrogen, carbon. What are the atoms attached to this carbon now? What are the atoms attached to the last carbon? Absolutely. Hydrogen, hydrogen, hydrogen. So, which one should be number 2 and which one number 3? Which one number 2 now? Which group must be number 2? The propyl, absolutely. So this must be number 2 and this must be number 3. That's actually how we apply the rules here. Do you follow me? That's actually a very, very important example, and of course it's straightforward. You must find a decision. طيب, the question is, what if someone keep comparing further, but he didn't find the decision? What does that mean? If we couldn't find the decision when we compare two groups, we kept comparing, but at the end we didn't find any differences. What does that mean? Wonderful, Fatma. You're absolutely true. That means if you cannot find a decision, that means the two groups are the same, which means the whole chirality option has been destroyed. There is no chirality, there is no stereocenter, so there is nothing to talk about. Do you follow me? That's actually the case. That's why what I'm saying, if you find that there is a stereocenter, then there must be a decision between the groups. There cannot be no decision. That's the whole case about the second rule. I hope it is clear so far for the rule number 1 and the rule number 2. If there is any question about these two rules, any question? All right. Now let's deal with the last group, which is the multiple bonds. How we deal for the priority assigning, how we deal with the atoms which are multiple bonded to the carbon or whatever. This here, we deal with the multiple bonds as if they are the double bond as if it is twice bonded, the triple bond as if it is triple bonded, and so on and so forth. In other words, let's say the rule 3, treat, let's say like this, treat multiple bonds as if they are bonded different times. All right, what does that mean? Let's take specifically an example. So C double bond O hydrogen, and we have C triple bond C hydrogen, and then we have Br, and then we have hydrogen. All right, let's take a specific example for rule number 3 and see how we can deal with it. Right? Now, very obvious that the atomic number of the bromine is 37, the atomic number of the hydrogen is 1, the atomic number of each carbon is 6. So when we compare the first rule, which is simply the directly attached atom to the stereocenter, it's very obvious which atom must be number 1 in this case. Which atom must be number 1? Which one is the highest priority atom in this example? Bromine. So this definitely must be number 1. Which is number 4 for sure? That's needless to say. Whenever you have a hydrogen in the atoms directly attached to the stereocenter, then by default this hydrogen must be number 4. By default. So in any stereocenter attached, whenever we have a hydrogen directly attached to the stereocenter, then definitely it must be number 4, because there is no atom which has lower atomic number than the hydrogen. Or in other words, hydrogen is the smallest atomic number in the whole universe. You follow me? Now the question is how to compare these two carbons. So as you can see here, we cannot compare it directly. So what should we do? We are now dealing with rule number 3. So in order to compare, as we said, we need to compare now these atoms here, this carbon and this carbon. Let us see what we have here. What we have for this carbon. We cannot, as you can see, we need 3 atoms here to be, to compare. In this case, what we should do, just focus with me please. What we should do, we should imagine, just imagination. It has nothing to do with reality. This is just for the purpose of nomenclature, for the purpose of giving R or S. We should imagine that this carbon is double bonded. Now, focus with my words. This carbon is double bonded to the oxygen. It means we should treat it as if this carbon is connected twice to the oxygen. Is that clear? In other words, I should make it like this. I should remove this and imagine that there is another oxygen attached to the carbon. Similarly, this oxygen was double bonded to the carbon, so it means this oxygen, as if I treat it as if it is connected to another carbon. So this is how we treat and how we deal with multiple bonds. So we deal multiple bonds as if they are connected to the same atom, twice if it is double, 3 times if it is triple. These are actually the 2 cases. There is only double bonded or triple bonded. Clear, guys? Any question? Please go ahead. Who wanted to ask a question and then change mind? Please, if there is anything not clear, just right away ask. Don't hesitate. Because these are very, very important. As I said, as I keep repeating all the time. Very tiny things, but these are very important. Once you understand them, there will be like bases for your whole understanding. If you don't understand them, that actually will affect badly all your understanding. So please ask if there is anything related to dealing with multiple bonds in priority assignment. You follow me? Clear? All right, perfect, Maria. Again, it's just a rule. The rule here, Maria, and anyone else. Now, if an atom double bonded to another atom, we deal with it, this is the rule, we deal with it, we imagine it as if this atom, if it is double bonded, it means it is bonded twice. If it's triple bonded, it is bonded 3 times. Yani, in other words, if this is a stereocenter attached to carbon double bond O carbon, so for example CH3, what are the atoms attached to? All right, we just finished. What are the atoms attached to this carbon? Here we should know that there is a carbon which is this carbon, isn't it, Maria and everyone else, right? The carbon here is clear because it's single bonded. Like the double bond here, we should treat it this here, we remove because it's double bonded. We remove this double and we think or we treat it as if another oxygen. Yeah, this carbon is connected to 2 oxygens because it was double bonded. The same thing, because this was double bonded, we treat this as if it is attached to another carbon. Clear, Maria, now? Now, so what are the atoms now attached to this carbon? Will be carbon and 2 oxygens in order to compare. Because always for the comparison, once you cannot determine from the directly attached atom, you want to work further, then always you need 3 atoms to compare. Always 3 with 3, 3 with 3. So always you need 3 atoms. This is the rule how we get 3 atoms from the multiple bonds. Clear, guys? Wonderful. So let's simply deal with this carbon. Now, here, we see with this carbon, it is triple bonded. So the carbon here, with this arrow, this carbon is triple bonded to another carbon, which means I must think of this carbon is bonded to 3 carbons because it's bonded, it's triple bonded. So I remove the first, I add a carbon. I remove the second, I add another carbon. The same applies to this carbon too, because if you need it for any further comparison, so you need another carbon and another carbon. This is how we deal with triple bonds in assignment of the rules. Is that clear? So in this case here, this carbon is attached to carbon, carbon, and carbon. So how to compare? Now you see, where are they? So this carbon is attached to hydrogen, oxygen, oxygen. Now, which one is more or higher priority? Hydrogen, oxygen, oxygen, or carbon, carbon, carbon? Which one has higher priority? Remember, the oxygen is 8, the atomic number, and the hydrogen is 1. Carbon, each carbon is 6. Right? Which one is higher priority? Carbon, 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 or oxygen, oxygen, hydrogen? Why, Aisha, carbon, carbon, carbon should be higher priority? Why? Okay, all right, very nice. This is, I like it. Some of you said this has higher, which is totally wrong. Why? Because some of you made it like 3 times 6, which is 18. This is not the way we do it. We just here, because simply if you count this, this will be 17. This is not the way. We don't never sum the atomic numbers. All what you have to do, just compare the 3 with the 3. If you find one atom here or there, one atom higher than others, fine, definitely. Even if you find only one carbon, got my one atom only. For example, once you see one atom here is higher atomic number than others, done. You don't need even to continue comparison. So that's actually the higher atomic number compared to this. So this must be number 2, and that must be number 3. Got it? Clear? Is that clear how to assign the priority? Anyone else? So the whole issue, just to repeat it again very quickly, yani once you have the 3 atoms to compare, all what you need to do, just compare, if there is only one atom has higher priority from the 3, from these 3, that's it. This will be higher priority. Never, ever sum the atomic numbers. We don't do this. This is not the rule. The rule just compare. Compare the 3 atoms there with the 3 atoms there. Is that clear, guys? Any questions so far? Aisha, I don't understand your question. Can you repeat your question, please? Or speak up, maybe it's better, if you can. Aisha. All right, Aisha, maybe I got your question, if it is difficult to speak up. Okay, I got your question, Aisha. I know what you mean. Aisha, saying that here carbon is higher than hydrogen, why not then this is higher than that? It's very simple. Don't complicate things in your brain. All what you need to know. Look here for the 3. What's the highest number here? Here. What's the highest number? Aisha and anyone else. What's the highest number of atomic numbers of the 3? Among the 3? 8. What's the highest number among the 3 here? Aisha, what's the highest number among the three? Done. خلاص. Done. 8 is higher than 6. That's it. Got it? Wonderful. That's actually the whole issue regarding assigning the rules. I wish you all actually that you study it carefully for the next lecture, because if you don't study this lecture deeply and carefully, that will make our life so difficult in the next lecture. So you must fully understand this lecture before continuing for the second lecture of this chapter. Because that Aisha is asking a question, a very nice question. So why we repeat the double and the triple, so we can decide without that? Of course, Aisha, but sometimes you have, two atoms are the same, so you need to look for the three together. In other words, let me just give you one final example, and then we end up this. For example, here. Here, for example, if I want to compare the priority of these two groups, which of the two groups are higher priority? In this case, we need to look here the three atoms. Here, the carbon directly we cannot decide, so we need to deal with the double bond. So this here will be carbon, this will be oxygen. We remove this, this will be carbon, this will be oxygen. Now we can compare. So this carbon is connected to oxygen, oxygen, carbon. This carbon is connected to oxygen, oxygen, carbon. Further, then we will find that this oxygen is connected to carbon, while this oxygen is connected to hydrogen. Then that means this group is higher. So what we need, you need just to make the analysis similarly, always to compare three atoms to three atoms until you find a difference. ولا يهمك طيب. I am not in a hurry. So these two groups, that's very important. This is higher priority. You know all what you need, guys. All what you need to do simply to practice more. By the way, starting from this chapter, we will have, for every chapter there will be an assignment. So at the end of this chapter, there will be assignment for the whole chapter. So covering all aspects of the chapter. But for the time being, please practice as much as you can how to determine the priority of all atoms attached or directly connected to the Stereocenter. Because this is a fundamental knowledge. You must have it before proceeding further for the next chapter. Is that clear, guys? Okay, so inshallah, as I promised you, today at 2 o'clock, then we will have, we said at 2, right? We will start at 2. Is that clear? Or 2:15 shall we start? Okay, we'll start 2:15. We'll start 2:15 exactly like that, the lab time. We'll start 2:15, and then we will discuss if you have any question about any topic you would like to discuss in the organic chemistry. So please prepare your question right away, and if you can, just directly prepare. For example, say this question is from edition 9, page whatever, question so and so. You know, just to make things as easy and as fast and as efficient as possible in order not to waste time. Thank you very much for attending the lecture, and inshallah see you in the next lecture after a few hours from now. Thank you. Salam.